Good day. Welcome, dear listeners. I'm Elijah de la Cruz, your host for today's podcast. And in today's podcast, we will be discussing the practical applications of calculus in the modern world. First off, let us define calculus. Just what is calculus exactly? In simple definitions, or in simpler terms, calculus is a branch of mathematics that deals with the study of rates of change and the accumulation of quantities. It includes concepts such as limits, derivatives, and integrals. Calculus, then again, is divided into two main branches: differential calculus and integral calculus. First off, with differential calculus, it deals with the study of the slopes of curves and the rate of change of one quantity with respect to another quantity. Or, in simpler terms, how the quantity changes as its input changes. Integral calculus, on the other hand, deals with the summation of quantities, unlike differential calculus, where we are concerned with each of the little bits of a function. Integral calculus gathers all of those little bits of the function and then adds them to get the whole. Now that we have a bit of background of calculus, let us now dive deeper and explore two major areas wherein calculus plays a pivotal role: in engineering and construction. And today, we have three brilliant guests who will shed light as to how calculus is an integral part of engineering, as well as its practical applications and how they can be used in construction. For our first guest, we have the pleasure of inviting over the Einstein of BSCE 1A, the one and only Edcel John Ancheta. There we go. Welcome, welcome. Solid handshake. Please sit down. Please sit down. Okay, so thank you for taking the time to come here.
Likewise for an invitation.
Okay, so I've heard a lot about you, and I know that you know a lot about calculus and that you know how calculus pretty much works, no? And so I'd like you to enlighten me or to discuss to me today about the importance of calculus in the field of engineering, as well as give some of its practical applications.
Certainly. So sa engineering kasi, calculus is like a toolkit that helps us design and analyze systems with precision. For example, yung design ng isang bridge, calculus helps us to understand forces and yung mga stress na nag-act dun sa bridge na yun, and as well as determining the optimal shapes for that bridge for to ensure its structural integrity. Pero sa engineering kasi, hindi lang naman buildings and structure. Some also use calculus to precisely design vehicles. For example, yung the designing of high-speed train, like the ones in Japan, yung bullet train ba. So, when designing a train, engineers must consider the force that act dun sa train na yun, the friction between the wheels and the train, as well as the aerodynamics ng train na yun as it reaches high speeds. So, by applying calculus dito, engineers can optimize maximum efficiency and safety dun sa trains, yung design ng train, all the while keeping the cost of production and maintenance at a minimum. Marami talagang kino-consider kapag engineering. Even though na some or most people say na, ay, engineering, solving lang dyan. Well, this is partially true. Engineers are not just solvers. They dream and build to shape this world. So, in conclusion, calculus is an engineer's power of creating and building, and it is their lifeblood in the field.
Calculus is their lifeblood in the field. Wow, I'd expect nothing less from you. It's a wonderful explanation. So I suppose with this discussion, rather, we can say that calculus truly is an all-rounder toolkit, no, in the field of engineering in various instances, as you mentioned, from the designing of bridges to the designing of vehicles such as the trains. Calculus truly is the go-to toolkit, no, for engineers as they apply or practice their profession in engineering. Thank you very much for your time and thank you for your wonderful explanation. Moving on, Our second guest today hails from the city of the book, home to the widest roads in the north. None other than Joevincent Bumosao. Welcome, welcome. Please sit down. Please sit down. Okay, go on.
It's a pleasure to be here.
Well, it is certainly a pleasure to have you here, Mr. Vincent. Now, we previously discussed the role of calculus in the field of engineering. And now, I suppose it's high time we discuss the role of calculus naman in the field of construction. So by all means, do enlighten me.
Of course. So, maraming gamit ang calculus sa construction. However, I'd like to focus dun sa backbone ng construction implementation. The so-called cost analysis. Cost analysis is a critical process in construction project as it is the comprehensive breakdown of all the costs to be incurred in performing any activities per project requirements and specification. Now, sa maxima at minima, it plays crucial role sa pag-finance ng isang project. Let me explain this. Sa mga construction project, dapat na i-consider ang cost incurred by variables such as materials, labor, time, and more by using the concept of maxima minima. Taking the derivatives and equating the variables to zero, we can find critical points. These are where the cost function reaches maximum or minimum. This will enable us to know kung magkano lang yung gagastusin sa mga materials, kung ilang laborers lang ang dapat i-hire, and so on, ultimately allowing us to minimize our expenses to have potential savings in the long run.
So basically, maxima and minima can be applied in the field of construction to save, typically and practically to save more, waste less, no? So I suppose that concludes your discussion. Thank you very much. And finally, we are off to our third guest, the recruiter of the group, as well as a distinguished Polinian departmental officer. Please welcome Mharianne Gumpal. Yes, welcome, welcome. Please sit down. Now, in our previous discussions, we discussed from the first two guests about the practical application or how calculus works in the field of engineering as well as in construction. Now, I would like you to highlight, or rather give an emphasis on how calculus is of an importance to those said two fields.
Sure. As we've heard from the first two guests, calculus bridges the gap between theoretical concept and real-world applications. In engineering, calculus is the go-to toolkit when engineers want to be precise in designing structures as well as vehicle as mentioned by the first guest.
So, sa engineering kasi, calculus is like a toolkit that helps us design and analyze systems with precision. Some also use calculus to precisely design vehicles. For example, the designing of high-speed train.
From the designing of bridges to the designing of vehicles such as the trains, calculus truly is the go-to toolkit for engineers.
And in construction, specifically in cost analysis, calculus serves as the guiding hand for construction professionals that allow them to make decisions that only minimize costs but also maximize efficiency.
Now, sa maxima at minima, it plays crucial role sa pag-finance ng isang project by using the concept of maxima minima. Taking the derivatives and equating the variables to zero, we can find critical points. These are where the cost function reaches maximum or minimum.
Maxima and minima can be applied in the field of construction, typically and practically to save more, waste less, no?
In totality, calculus grants engineers and construction professionals a somewhat holistic perspective that allows them to approach their work with a deep understanding of the mathematical concepts and principles related to their respective fields. As said by the first guest, it's not just about solving equations, and I think it's all about making calculated decisions that shape the world we live in.
Calculated decisions that shape the world we live in, indeed. What a very comprehensive explanation, Mharianne. And I'm pretty sure the first two guests would have loved to have a trio discussion or a trio engagement with you had our podcast been able to accommodate three at the same time. But no wonder, your explanation is quite clear and as concise as it can be. Thank you very much for your insights and thank you very much for your time. And there you have it, dear listeners. 3 successive, enlightening, and very informative discussions about the fields of engineering and construction, which of course is weaved all together by the intricate threads of calculus. Now, as this podcast comes to a close, do remember that the solutions to tomorrow's challenges lie within the equations of today. Stay inspired, stay calculated, and continue to push the limits of innovation. Until next time, this has been your podcast host, Elijah de la Cruz, now signing off.